Hello everyone, this question is about integration. Hence show that, so from the previous part about partial fractions, we know that the f of x is this guy, this is the f of x from the first part. So now we integrate, so we have these integration formulas in the MF19. So if you look at the first term 2x minus 1, there is no way we can integrate this directly because there's no shortcut formula in the MF19. So we're gonna have to split the fraction 2x over minus 1 over. So we have to split the fraction like this. Okay, now if you look at this 2x over 4 plus x squared, this is actually in this form because the numerator is the f prime or the derivative of the denominator. So if you look at this denominator, the derivative of this is exactly 2x. So this guy is the f, this guy is the f prime, which means we can use this rule. So using this rule, we get ln the denominator. So that's why we have ln 4 plus x squared. Now for this, we need to use the inverse tangent rule in MF19. So notice that instead of x squared plus 4, I'm writing it down as 2 squared, because look at this formula here, we need to identify the a, so something squared, the a is 2 then. So if we apply this formula, we know the a is 2, so we have 1/2 inverse tangent x over 2. And for this part, we use the usual ln formula. So we have 1 over becomes ln, 1 over becomes ln, the denominator. So now we just have to plug in 2, replace the x with 2, replace the x with 0, and then subtract. So since we are showing something exact, you cannot use the calculator for the whole thing here or the whole thing here because you might get decimals. So if you get decimals, that means you gotta chunk your calculator work. So do the calculations by chunking. If you do this part only, see if you get decimals or not, or exact value. Unfortunately for ln, you will get decimals here. So for this part, you can only use your calculator for 4 plus 2 squared, which is 8. Now from here, you can use your calculator for the whole term because you will get something exact. Or if it's not exact, you gotta use only this inverse tangent. This is inverse tangent 1, which is 45 degrees, or pi over 8 actually. I mean pi over 4. Okay, pi over 4 divided by 2 pi over 8. Right, and if you use your calculator, you get decimals, so you can only use your calculator for 1 plus 2. Not that you need it. So you have 3 ln 3 from here. And from here, again, there's nothing you can do, just write ln 4. And from here, it's okay to use the calculator because you will get exactly 0. And from here, it is okay to use a calculator because you get exactly 0. So now we simplify. We have ln 8 minus pi over 8. So from we get this. And for this guy here, we use the logarithm rule. We can move this coefficient or this number inside the argument. It becomes the power of this 3 here. So 3 to the power of 3 is 27. That's why we get ln 27. Okay, and we still have minus ln 4. So now we combine all the ln. So when combining ln, just use a division line, and then if it's a positive, you put it on top. If it's a negative, you put it below. So we have 8 times 27 divided by 4, because multiplication means addition if you split, or if you combine addition becomes multiplication, and if you combine subtraction, you get division in the argument. So you can simplify here. This is 2 times 27, which is 54, which is what we need to prove. Alright, I'll see you again next time.